the chat is the link to the questions document where you can add your questions as we go. I will explain how that document works in a minute. Our topic today is small language models and the future of agentic AI. It's an interesting paper, interesting hypotheses being posited. I have my thoughts about them. It'll be interesting to see how you feel about them. We have three illustrious speakers as always. Nihil Jain, who is, Sonam Gupta, who is a senior developer advocate at AI Explain, and really happy to have her. Adam Becker, who many of you know because he does a lot of these. He's the founder of Head On, which is a website for political activism, and it's a pretty interesting site. I urge you all to go take a look at it. Adam's doing some pretty important work. I will also tell you that he is a graduate of Berkeley in both astrophysics and classical history, Greek and Roman history. And I did promise him that he's always going to get a question about ancient because I love the history of that period. I was going to give him a question, but given limited time, Adam, I'll let you off the hook today. But it was about, I'll warn you, the next question will be about the 14th emperor of Rome. So we'll go from there. They made a famous movie about him. And then we have Nihil, who is in a stealth startup right now. He has quite the background. He's ex-McKinsey and ex-Quantum Black. And by the way, at the bottom, you see our LinkedIn addresses. If you wish to connect with us, I always urge you to connect with us. We love to be, part of the community. That's why we're here, and we're always happy to have conversations with you one-on-one. The agenda today is Sonam's going to kick us off with the introduction and definitions, and that's important, like what is a small language model? That's not an obvious definition. And then the problem statement. Then Adam's going to review the arguments that are put out by the authors in favor. Nihil is then going to talk about barriers and the way we have to adapt to them. And in between, you're going to see surveys, polling questions pop up. In particular, one should be up, if not now, because I can't see the screen, about whether people have read the paper in advance. This is important for us because it tells us we're trying to find out how often people are actually reading these papers in advance because it's how we prepare to speak. So if you wouldn't mind answering that poll in particular, it'd be great. As always, the guiding principles of the reading group are that these sessions belong to you. They're intended to be interactive. We talk for about 35 minutes. We all discuss, including you, the 25 minutes. That's why we want you to do the questions. And of course, the more we all participate, the better it is for all of us. There are no dumb questions. I always like to say this is a no judgment zone. And you should always feel safe in here to be able to ask any question you want. I was on a call yesterday. It was a PhD thesis presentation. And I had three questions, and I didn't ask them. And I later talked to the speaker who graduated from MIT yesterday. And he was like, well, why didn't you ask those questions? Those are great questions. And I was afraid, not being a physicist, a PhD physicist, to even ask any questions. So there are no dumb questions. And the Google Doc link is shown where the questions will go. The questions will be answered in the order received. So like a stack on a computer chip. And then please, for our sake and for the sake of getting better for you in the future, please fill out the post-event survey that will come in your mail. Really appreciate. We read those comments and we will use them to help prepare how we do things in the future. Now, lastly, this is not something I normally do, but I always read in preparation for these events the references. Not all of them, obviously. There were like 80 references on this paper, but one of them, which is 66 from Subramanian, it was done in March of this year as a survey of small language models and how they work. And it's basically some of the major research that's quoted in this. I wouldn't worry too much about the left side of this diagram. But what I like about this side is it shows all the small language models that they have sort of looked at, and it categorizes them based on the approach to getting there. And I thought this was an interesting way to frame the discussion and whether transformer-based, reparameterized, additive, or hybrid models really work better than others. I don't know that we'll get to that, but it'll be interesting if we can have some conversation about that. And with that, I will turn it over to our first speaker. Sonam, are you ready?
Yes, I am. Thank you, Arthur.
Let me let go and stop. How do I do that here? And we're being recorded.
Yep.
Did I let go? Yeah,
Yep.
I let go.
Thank you, everyone. Everyone's doing very well. I'm very happy to be back here. And I'm going to share my screen quickly.
What you're doing now is the results of the paper. It's interesting. The majority of folks have read it or skimmed it. That's about 60% so far. So thank you. That's great and feedback for us,
Awesome.
guys.
Well, if we are ready, then I can start. Okay, perfect.
Go ahead.
All right, so as Arthur mentioned, the paper today we're discussing is small language models are the future of agentic AI. Now, the QR code that you see on the right side of my screen, it's my LinkedIn profile's code, and if you wish, feel free to connect. Would be happy to have a chat later. Um, but let's get started. Now, so small language models are the future of agentic AI. That's a huge claim, the paper says, which kind of makes sense too, if you think about it. Now, the basic overview of this paper, it's challenging that even though bigger is better in the AI agent systems, it argues that the small language models, not the LLMs, not our usual LLMs, are better suited for building much effective and faster AI agents. So, this research basically demonstrates how smaller, more specialized models can basically do better, outperform their larger counterparts in AI agents while being more economical and operationally efficient. Now, there are two working definitions of small language models in the paper. The first one, it says around that it is a language model small enough to run on constrained compute with low inference latency. As we know, large language models, we need a huge amount, like it needs an infrastructure to have it run smoothly. It needs better latency, it has a lot more parameters, and so on. The other working definition they have, which made me chuckle a little bit, is that a large language model is a language model that is not a small language model. So it was a little confusing there, but the first definition, it made sense to me. Now, before we get started, I want to just take a quick overview of what AI agents really are. AI agents, so the way I define is that AI agent is a system where LLM or a large language model is the brain, whereas when it uses the tool to do more autonomous tasks depending on the query. The best part about agents is the autonomy. It breaks down the complex task into manageable steps. It makes decision based on whatever context and objectives you provide. It calls the external tools and APIs to accomplish these goals. And as I said, like the language models are the brain to the agent so that it can do the reasoning part. And then it adapts to feedbacks and the changing conditions. Now, the way the paper has positioned, or the authors have positioned their hypothesis, is in three ways. First, they say that small language models are powerful enough. Basically, they have shared like what are the recent advancements in smaller models. They have much sufficient capability for majority of the agent tasks without really needing or adding that overhead of using the large language models. The second way they have positioned is that small language models are more operationally suitable. So basically, they offer better latency, less usage of the memory, and then much simpler way to deploy your agents in production. The third one is small language models are more economical. I mean, if it's using less latency, less parameters comparatively speaking, it's of course economical for people to use it because it reduces the cost of training, fine tuning, and inference in production environments. So basically, yeah. So this is what the authors have positioned the paper or their argument. The evidence that they have showed they have compared a lot of different models. So for example, to especially to support their first argument, which was that it's powerful enough. Now they have given examples such as Microsoft's fee model, where it matches like around 30 billion models, or the fee 2 is around 2.7 billion. It matches the 30 billion model a comparison on common sense and coding, it basically runs 15 times faster. V2, on the other hand, it's matching the performance of models that are 70 billion parameters on language and reasoning. Same with similarly with NVIDIA family or Nemotron have these models yet, but overall, all these models that you see on the screen are the examples that the authors have actually given, where they're showing that small language models are much capable comparatively to their large language models counterpart. So that's all, and I am going to pass on to Adam to share us the next points. Over to you, Adam.
Awesome. Thank you very much. Okay, I'm going to share my screen too. And we made a little Miro board, so maybe we can share this one as well in case people want to follow along. Would people like that? If so.
Do you have the link? I've got the link. Okay.
Okay, cool. Yeah.
I'm putting it in chat now for everybody. It's there.
Awesome. Yeah, if you want to follow along. So we have the paper laid out here page by page. But especially for the purposes of articulating the arguments, we thought it might be nice to just see it all in one view as kind of like a big diagram. So let's start here. So, okay, their major claim is small language models, they're going to be the future of agentic AI. And one theme that you're going to see them continue to come back to is what we can call the Lego theme. So it's just scaling out by adding small specialized experts instead of scaling up monolithic models, right? That's the intuition here. Instead of thinking about a very large language model, it costs whatever millions of dollars. This is it. Just start with very small, very expert, very purpose expert models. That's going to yield systems that are going to be cheaper, faster to debug, easier to deploy, and better way we're actually going to see in the real world. Right? So that's the intuition here. And I think Nihil and I were texting about this. It's almost like they have that type of intuition, and it could be a blog post, whatever, but they ended up making this into something that's a bit more structured to really like drive home the point and be very precise about the argument. So this is the shape of the argument. The conclusion is they believe small language models are the future of agentic AI. Why do they think that? So Sonam already spoke about these three different views. So put a little brain icon here. You can just consider this the powerful enough view, right? Small language models, they're sufficiently powerful to handle language modeling errands of agentic applications. So they're good enough. Even if you want to make the case at some point, you were going to see that the large language models are even better, might be even better, but these are good enough. So why do you need the better? So that's the first view, powerful enough view. Second one is the better suited view. Because of how agents operate, and we'll zoom into that, small language models are inherently more operationally suitable for use in agentic systems rather than large language models. So it's just they're better suited. And last is they're going to be cheaper. So small language models, they're necessarily more economical for the vast majority of language model uses in agentic systems, much more so than their general purpose LLM counterparts, but because they're smaller. So by virtue of them being smaller, they're also going to be cheaper. Okay, so now let's investigate the arguments and then some of the counter arguments to those arguments, and then the rebuttal to the counter arguments to the arguments in support of these views. Okay, so powerful enough view. The first is the good enough argument. If you look at competitive off-the-shelf performance of SLMs versus LLMs, in those places where it matters, and Sonam spoke about this, where it matters, SLMs are just as good. So you really don't need to worry about any of the other stuff. Next, they jump around a little bit because I think they're trying to build a case. So in support of the powerful enough view, Sonam showed you on benchmarks, small language models are doing just as well where it matters. But what about on the cheaper view? You have the economical argument, which I think is a pretty interesting one here, because they break it down into a few different dimensions. The first is the inference efficiency, right? So serving a 7 billion parameter SLM is 10 to 30 times cheaper than a 70 to 175 billion parameter LLM, right? These are insane differences, right? So they're like, of course it's going to work. Of course, this is ultimately going to win out. It's so much cheaper. Next, because they're small, you don't have to deal with parallelization across GPUs, across the different nodes of GPUs, and because of this, it's going to be even cheaper to maintain and to operationalize, even just the infrastructure. So forgetting about just the inference itself of serving, managing the rest of this is going to be much easier. Next, fine-tuning agility. Because they're small, and especially if you use parameter efficient methods, but even if you just go for full parameter fine-tuning, requires only a few GPU hours. You could just go to sleep, you wake up in the morning, the thing is fine-tuned. You don't need to now spend weeks, trying to fine-tune these models. Edge deployment, you could just deploy these things on consumer-grade GPUs. You don't need any specialized infrastructure for it. And they even mention in the draw references to a lot of people doing all sorts of interesting like LLM stuff or just language modeling on mobile devices. Parameter utilization, they're fundamentally more efficient because if you look at the percentage of parameters that are actually activated in the large language models, it tends to be very, very small. And so that isn't the case. So they're much more for the small language models. So they're much more efficient. So because they're much more efficient, they utilize parameters more efficiently, the whole thing is going to be cheaper. That's the economical argument, right? So economical argument goes into the cheaper view. All right, next, they make an argument about flexibility. So they say small language models possess greater operational flexibility in comparison to LLMs. And the shape of the argument then looks like this. Because it's cheaper, it's more practical to train and adapt and deploy multiple specialized expert models for different agentic routines. Here they start to slide into slightly different. Oh yeah, so this is, okay, so first it's cheaper and therefore they're more flexible, so it supports the cheaper view. But this one also supports the better suited view. Why is that? Because if it is cheaper, well, then more people can play with it and more use cases can be solved and can be addressed. And because of that, you might even introduce less bias, because if somebody has a bias in the deployment of AI, at some point, maybe those biases will cancel each other out. You're going to have more perspectives. More people actually have a stake in the success of these systems. So it's more suited for agentic systems and it's cheaper. So that's the flexibility argument. Let's now jump back to the powerful enough view. Okay, so if you think about all of the uses, all of the actual skills of a large language models, very few of those skills are actually used and utilized during agentic processes. Agentic applications are interfaces to a very limited subset of language model capabilities. So even if you could make the case that they're intelligent, it might be overkill, or that the large language models are more intelligent. It might be overkill. Why? This is kind of how they see it. If you think about what an agent is, they say, all right, let's say an agent is some tools and some heavy prompting and some choreography. So, you dance around like this and you play with the memory and then the tool, and then you bounce back and forth in different ways. And then you allow a human to interface with it in some way, via text or voice or whatever. Well, then really what you've done is you've squeezed a very large language model's capabilities into a relatively small subset of things. Okay, so that squeezing means that maybe you don't need that large language model in the first place. It's too large if you're doing all this squeezing. So just start with something much smaller. It's so much more fitting. So it's powerful enough. Small language models are good enough for these very small subset of the uses. That's the argument. I imagine some people can foresee maybe some of the counter arguments to this. So this is the intelligence overkill argument. Okay. This one is also just means that it's better suited, right? Not just that it's the powerful enough view. So better suited. Okay. We're pushing along almost, maybe probably halfway done. So next is the behavioral alignment argument. So agentic interactions, they necessitate very close behavioral alignment. Well, I almost call this just like the right formatting argument, because I think that's like the main argument that they're bringing up, which is this. Let's just imagine that right now you're building the app, right? You have an agentic app. There's a bunch of different agents doing different things, or different parts of an agent that are doing different things. you probably want a single format to communicate between the different parts. Maybe it's JSON or YAML or Markdown. And if the model knows too many things, maybe if the model has been trained on lots of different potential formats, like an LLM had been, maybe you're risking some hallucination here. But if you have a model that is small, that let's say has only been trained or has been enforced or fine-tuned to only really return JSON, you reduce the risk of it returning something that isn't a JSON, right? So you can be much more aligned with the intended behavior that you expect if it's small. So that's this argument. All right. Behavioral alignment argument. Next is naturally heterogeneous argument. Of all the different, just if you can imagine in non-agentic worlds, the agentic world naturally allows for a lot of heterogeneity, especially in the model selection. Why? Because it's supposed to be doing different things. When an agent invokes a language model, you could choose any language model. So why not choose the language model that's the best for the task? And that will probably push you to the smaller one. So different levels of complexity call for models of different sizes. If you have a particular task that requires the LLM, maybe that's fine, but most of them are unlikely to. This is, again, based on that previous argument, this one. Okay, we have another one, which is the interaction data argument, which I think this is the cutest argument they've had in the whole paper. And it kind of looks like this. Each invocation is itself producing data that can be used for optimization. So think about it. I think the best way to think about it might just be like in the alternative reality. So let's imagine that we say, no, we're just going to go with LLMs, no SLMs. Fine. But we know, as we said, that we're only really using a particular LLM for a particular task. So, and we're already getting a bunch of data about the performance and efficacy and effectiveness about this task. We know about the prompt. We know what the user did. We know whether it was downstream useful or not useful. All of this is data. And I said, okay, fine, I'm going to start with an LLM. I don't want the SLM. But now I have all this data. I have the data about the prompt. I have the data about the efficiency. Why shouldn't I further optimize just that one piece of the flow? And then I optimize, I end up with a small language model. So that's kind of how I see it. So we could just, if you're just to look, you start with LLMs, you just keep tweaking, you're going to end up with the SLMs. Okay, so I think that we're done with all the arguments in defense of this claim that SLMs are likely the future of agentic AI. So if people are persuaded, here are some counter arguments. So, okay, we have an alternative one. This one is an alternative to the better suited view. Empirical work shows the LLMs follow scaling laws, right? Sonam spoke about this: larger size, better language understanding across tasks. So this is to the point of saying, is it actually overkill? Maybe it isn't. Maybe what you do need is the ability to understand language in a more nuanced way so that you can even deploy the right agents or the right tasks. Maybe that interface can't really be managed all that well with a small language model. Maybe what's necessary is the large language model here. Okay, so that's an alternative view. There are some rebuttals here. So this is called I call this the reasoning rebuttal. So techniques like self-consistency and verifier feedback allow SLMs to trade extra computed inference time for reliability without sacrificing their lightweight deployment benefit. So even if it's the case that large language models, when you compare an LLM with an SLM, maybe an LLM still does better, and maybe you could still, the LLM would still be good enough. The LLM would still be much better, but SLM isn't just what you get out of the box. Maybe you can add more. You can trade extra compute, that inference time, and then at that point it could still be doing better. So there's some other tricks that you can do. And again, I think this is a rebuttal that's related to something we'd already covered. Simple subtasks, they just don't require the complex abstractions and understanding. Sure, the LLM is good enough, is plenty better, but for most simple subtasks, which is the domain of the agents, you don't need that. Okay, so that's one alternative. We'll tackle the other one next. So could it be the case that now managing a bunch of different SLMs is going to be expensive? Because you need to deploy new specialized infrastructure for it. And you need to build a whole now world that supports this. Maybe that's going to be too expensive. I think they are, I would say they're sympathetic to it, but ultimately they rebut it. So recent improvements in inference scheduling and large inference system modularization offer unprecedented levels of inference system flexibility. So yes, sure, but the trend is going to make it easier and easier. We'll have better and better tools to manage and orchestrate all these different systems or components of a larger system. And then the other the other rebuttal is most recent analyses on the setup costs of inference infrastructure indicate consistent falling trend due to underlying technological reasons. So again, tech will be able to meet us there, and managing the infrastructure is going to be less bad. So this is, I think, a summary of their argument. But I think they also leave one possibility here. They say it could be the case that while SLMs are better suited for the job and they might be cheaper, LLMs have a head start. And so maybe that's going to win out. They just started sooner. And so even SLMs might be better and cheaper. LLMs have a head start. They push back on this. They say, I think they're open to it, but they still think that it's much more likely that given all of these attendant benefits of SLMs, that's going to be the future of agentic AI. Okay, with that, I think I'm going to hand it over to Nahil.
Cool. Yeah, I think that makes sense. I will also go to
Nahil,
the
sorry,
same
I'll go to
meeting.
you. Before we turn it over to you, I want to go to the poll. It's a very important poll. It really has surprised me, actually. We had 66% of people participate, 32 of 48. And any of you who haven't participated yet, go ahead and add into this. But what's interesting is that we have 4 people who have tried this, and they found that they can run models as large as 10 billion parameters. But we've had 7 people who have tried this, and they have not been able to make models this large run in small memory environments. And frankly, I should vote because I would be 8 on that score. So that's interesting. And so that's 11 out of 32 who have tried it, but the majority have yet. So when we get into the conversation, folks, I would like to hear, please, from those who have tried it, what their experiences have been. And I'll try to find someone, but just come prepared if you wouldn't mind sharing with us your experiences. And now I'll turn it over to Nahil.
Cool. Yeah, thanks. Me report time. Is it? You guys see the right one? Nope, not the right one. This one. Okay. Yeah, so basically, I added some of the red stickies kind of similar to the alternative. So one thing they were saying that, powerful enough view that SLMs are powerful enough. But then I think Samantha was talking about this in chat, and they have this point that because LLMs have generalized in general now over international, like they can do multiple languages, multiple modality, they understand concepts at a much higher abstraction level, which is like how maybe the Asian world looks at a concept is different than the Western philosophy of it, and they understand both, and so they can kind of translate between the two. And that's one argument they have, that's why LLMs might be better. Intuitively, again, I still feel like if you're just going for automation, it doesn't really matter that much. You can fine tune for whatever your task is, but that's one of the alternatives. And then another counter argument they have for the cheaper thing is things that at least the MLOps community has known before, that you cannot get full utilization of the small language model endpoint. So like even if you have your own SLM, maybe the LLM endpoint will win when you average the cost of ownership because of the traffic you can drive to the centralized endpoint versus like these bespoke endpoints you have for your agents. And so they're like, maybe it doesn't matter and LLMs will still be better because of centralized endpoints. And the second thing is the talent and cost of managing each endpoint and each inference of an SLM for your agentic task is way more complex than just like the training of the LLMs and the large language model teams managing it in a centralized place. So those were two things I wanted to also add for the counter arguments. Okay, so for how do you solve for the barriers? So how do you I mean not
Wait,
solve for, but
Nail, are we supposed to see Miro or something else?
oh, what were you seeing?
We're seeing Miro.
Okay,
That
let
good?
me restart. I think something is wrong. I think it's the wrong Miro. I've been moving around, but I have two, three Miros open.
All right.
Give me one sec. Oh, I spoke so well that you guys didn't catch that. I was actually showing a Miro board. Uh, so nothing moved on the screen, huh?
Not
You're
yet.
showing Adam's flowchart from earlier.
Tricky. Okay. Is there anything moving now?
Okay, now you're
Yeah.
moving.
Oh boy. Okay. So first thing I was talking about was, LLMs are powerful enough, and the multimodality and internationalization is a counter argument from their side. So that goes on to like the intelligence and the powerfulness of LLMs over SLMs. And then the other piece I was talking about before was the economical argument, which is, hey, we can because the models are smaller and you can run them on constrained compute, you have efficiencies. But their counter argument is, maybe not because you have the utilization problem and the talent and the cost of actually getting them running problem. So sorry for the mess up on what I was showing versus what I was talking about. Um, okay, now we can talk about what are the other barriers. That's also kind of discussed. Adam just touched on it before handing it off about, LLMs have a head start. And so what that means is all the benchmarks and how you actually evaluate these different things is more suited for these frontier labs because they are designing the way to prove to each other that, mine is better, etc. And those are all LLMs right now. And so that's one problem. The other is there's a lot of investment that has gone into the LLM side of the things versus the SLMs. And so there's a lot more advertisements, there's a lot more talent being poured into the LLM side of things, pushing them ahead in the curve. And then it's just awareness. You don't have the same level of awareness for SLMs being used in agentic stuff. Most people, if you would have done the poll, answered the other way, where, have you tried LLMs versus SLMs? Most people would have tried LLMs, but not many people would have tried SLMs because it takes a slightly higher barrier to entry to try it on the constrained compute, etc. So that's their barriers. But they do say that our alternatives is still better, and so maybe there's SLM in the future. Now, if you have LLMs and you want to move it to SLMs, and you're convinced from all the arguments and the points of why SLMs will be the reason or the main way to build agentic systems, then they give out a kind of playbook of how you would go about it. And in my mind, that's very similar to the kind of, in older words, the MLOps playbook, and now it's the evals and AI ops. Like, we don't have a formal term for it yet. Playbook where you instrument your process, you kind of build the end-to-end loop, and then you instrument it. So you have all the LLMs taking the prompts, giving the outputs, and then your flow is going through. Um, and anything that doesn't have human in the loop, instrument all of those, and then you collect enough examples. Once you have those examples, then you do separation of those based on the different tasks that are being done, and then you build SLMs to become expert in those specific tasks. And this is kind of the same playbook you would run if you were fine-tuning something or improving the accuracy of a node or the whole agentic workflow. And that's what they talk about here. Another resource that I follow a lot, there's this course running around on internet, at least in my social media, by Hamel and Shreya. I think Shreya has spoken a lot on the MLOps community podcast and even in events. And so they talk about this eval framework to improve AI apps and agentic systems. And their kind of flow is very similar as well, where they're saying, hey, analyze it first, collect all the data with examples, and then measure based on what you think is accurate versus not accurate. So maybe manually label it if you have some other way to figure out, what is the accuracy and the correctness of the thing, and then improve it. And improvement can be either prompts or it can be fine tuning. So it can be either route. And I found that their route to the LLMs to SLMs looks very similar. So I think that's all. And then they're just asking for, let's have more discussion about it. This is very new,
Well,
which we are doing right now.
That's a good transition, Nihil. Thank you so much. You can leave these. What should we leave up? Should we leave Adam's diagram up because it may, prompt people for some thinking on stuff, or hopefully everyone's got it on their desktop because it's easier to see. Before we go into this, and this is a topic I want to make sure we cover, recent research shows that memory is a much more important factor in AI performance. In fact, in all computing, it took years to prove this mathematically. Although it's been suspected for years, a young man at MIT finally did it. And so the question I pose to you all here is whether you think memory is the real focus, should be, the ability to remember things and have a larger context window, and whether you think the emphasis should be on processing. We've had limited answers because it's kind of a hard question to read. I'll leave it up for now before we come to the conclusion on it. And before we get to the questions, I'd like to ask, let me just look who it was here. Samantha, is it? Did I get that right? Samantha Zeitlin, you've been talking about some experience you've had with small models in your application. Could we get you to spend a couple of minutes making this real for us, since you've already sort of opened up, and I'm open to anyone else having that after we get through the questions. But Sam, would you mind telling us about what you've done and what your experiences were?
Yeah, we've built a system to detect when you're having an outage based on your logs. So we needed a large language model that could handle the full context window. So we ended up using Claude with whatever it ended up being, 200,000 tokens. And we needed it to be able to do a holistic analysis and build out basically a graph, right? A chart of how all your services are connected to each other, which ones are having issues, and then make recommendations on what to do about it. And we did do some experiments using Llama for parts of this, and it just didn't work. We even had trouble getting any of the models to do well with tool use for like JSON validation. That's gotten better now, but a year ago it was really difficult. So I think the big piece that may be relevant for this group especially was we had to keep refactoring our code because we were figuring out which parts needed to be modular in which ways, and deciding to add additional models in would have made it even more complex. Rather than just having, a couple of APIs we were using, we would have needed to add more clients for more APIs, et cetera, et cetera. So we decided to try to keep our architecture simpler. And I mean, another factor for us too is the security aspect, right? Getting different models vetted by the company we were working with, getting them to approve it.
How much memory were you running in? What was your memory limitation on that?
Well, I was saying we ran into some issues where, like, running things in CI/CD, they only had 4 gigs of RAM on that system. And we were trying to explain to them that a lot of our use cases needed more memory, even just to handle the data, never mind hosting a model. So I think depending on where your trying to deploy these things, some companies are really not used to working in the AI space, and they're not even thinking about data engineering at this scale of, we might have data files that are 100 megs each streaming in essentially real time. So you definitely need enough memory to be able to handle all of that, plus whatever code you need to run. So that's another advantage to using a third-party model, is you don't have to worry about how do we allocate and scale the instances to host the models on top of everything else.
Thank you for sharing. Adam, you're showing your screen, or whoever's showing their screen right now. That was great. That certainly puts some context to some of the problems that the paper brings up, or some of the arguments it brings up. Let's go to the questions. The first question, and I'd hope people, if you've already put a question, could you put your name next to it so we know who it is? Whoever asked this first question, would you go ahead and put it out there in the ether? Do you think this argument holds? Who was that?
That was me. I'll chime in. Yeah, so this seems like it's talking about like the field or the industry or the state of the art a lot here, and more thinking as like a developer trying to build a product. Like, is there any room here still for off the shelf or like foundation models as a thing? Or is it really fundamentally saying like, no, you need to fine tune something for everything? Like this is your YAML model and this is your JSON model and those are different. And so do you agree that's what they're arguing? And do you think then that this is a viable proposal because people love to not have to do that work, and that to me seems like that's so much of the popularity of an LLM in the first place, is that you don't have to train it.
I think you bring up a really great point, which is we shouldn't all be training models for JSON validation. That's just dumb. There should just be a standard of practice that everybody can use.
I also think that a lot of people have empirically found recently that in general, prompt engineering is better than fine tuning, which goes back to the same cost of, your cost and talent of inferencing on these models and building these models and keeping them up to date is pretty high. So for that reason, I feel like, yeah, we can't go to the extreme of like everything is a fine-tuned model for your task. But there might be arguments where maybe what they're saying is that you might just move to SLM, which might be better at doing that specific task, which LLMs was doing. And maybe you can think of the SLM as a foundation. Like, let's say Mistral have a small model, which out of the box is doing pretty well on that specific task. And they're saying that might be the world you might live in. And you don't even have to fine tune. But yes, I don't think fine tuning and creating so many versions of SLMs, I buy that future a lot. Like maybe part of it, but not fully.
Yeah, I have a perspective on this too, where mostly in like when I'm still in founding a company mode or like trying to build a new product mode and I'm chasing product market fit, the last thing I'm going to do is right now break apart my system and try to do that. Would be crazy, right? Like all I got to do is just see if users are going to use it. So I wonder if the way that they would distinguish this is like by number of new experiments run, or in terms of actual calls and invocations served. It could be that once you hit some scale, then in that case, of course, everybody should be using these SLMs or whatever in some conjunction with LLMs for their agentic systems. But when you're still experimenting and you're not yet at scale, I would not spend, I think, more than a few minutes trying to experiment on an SLM at this point. This is how I'm likely to run things until shown otherwise. If somebody has a different perspective, though, yeah.
Other comments? Nihil, anything? Okay, let's move on to the second question. I don't know who this was. And I think they are two separate questions, 2 and 3. I don't think they're the same person. So whoever had question 2, you still there? All right, I'll do it. Does the paper mention the suitability of SLMs for... Sorry, what?
Hey, this is Dylan. Can you hear me?
Yeah.
Sorry about that. Yeah, so mine is actually like these three separate parts. But yeah, the high level is basically, how does reinforcement learning and like reinforcement learning on like, agent specific or application specific tasks kind of fit into the usefulness of small language models. So I think one point where like I think of reinforcement learning is interesting for like agentic use cases is like coding agents where or like mathematical agents where you like have like a result that you can really evaluate like binary like good or bad, but also just where you can define an eval with an LLM as judge. You can also do reinforcement learning there for your application specific tasks, and I think that's something you can do on any of these large language models that have open weights or have like fine tuning interfaces. But I kind of wonder if that's like more appropriate for small language models. I actually didn't get to read the paper, but I did a control F real quick and didn't really see it mention reinforcement learning. So I'm curious if anyone like has any thoughts or like experience with actually using RL for like task specific training.
So I can tell you our experience with RL was that it was too hard to get humans to give feedback, especially in some use cases where you need like subject matter expertise to evaluate whether the outputs are correct. It's really, really hard to get enough people to look at enough data points to be useful.
And now that
Yeah, that makes
AI is
sense.
gone, it's even harder.
Yeah, I think I want to look more into the agent reinforcement trainer where it tries to get around that, I think, by using an LLM as judge. And, I think LLMs as judge is like maybe a difficult thing to get right. But maybe there's certain areas where it can actually be pretty accurate and useful.
Yeah, so Dylan, one of the things, if you see the screen right now, is like they were saying that LLMs are more intelligent versus SLMs, but the authors argue that you can use. They don't necessarily say RL, but they talk about things like because inference is cheap and because you can have expert type models, you can train a model to be better at judging. So LLM as a judge, or you can do self consistency where you're like, hey, I'll run the same prompt n times instead of once, and then find the majority vote of the calls and then use that as an output. Um, or you can have like another LLM which verifies the feedback, which kind of is, it's more like LLM as a judge rather than RL, but they do talk about that a little bit. And they say that because it's cheaper to run them, you can easily do that with SLMs and get them to the same or even better quality than LLMs.
Any other
Yeah,
comments?
thanks. I think the cost and the latency makes a big difference in being able to do that. But I think that's all I have on that. Thanks.
I just wrote this in the chat, but I'll just say it out loud in case people aren't following that. We did a lot of work with LLMs as judges, and I just want to point out that it's another whole project in the sense that you have to do another whole round of prompt engineering and a validation to make sure that the judge is working correctly. And I think a lot of people are very nervous about that. So our clients at least also want to see human validation on anything that you use an LLM judge for. I think a lot of people are still going to feel that way for the foreseeable future. So that's another thing to keep in mind. It's not that trivial to get a judge that works really well unless you have really deterministic outputs, in which case you probably don't need an LLM.
Excuse me one second while let's somebody in. All right, question 3, and I love this question, and it's one that I'll phrase a little bit. Sergio, do you want to go from here since it's your question?
Thank you, Arthur. Yeah, I wasn't quite sure whether the paper was replacing any participation of LLMs. That was the suggestion for SLMs, and I was very compelled by the argument that language can be complex, and hence whether a hybrid approach of calling in of that LLM digesting what is happening and orchestrating the whole process, and then being able to possibly summarize in a domain-specific way and hand over the task to the relevant SLM that has been trained for a particular task. Is that what you were thinking, Arthur? What you interpreted?
Yeah, I'll put the question in a very specific way in terms of if you have a supervisor agent versus the subsidiary agents running under it, do you have the supervisor agent using an LLM, but the actual agents who are doing the specific tasks using an SLM as an option? So, Sergio, that sort of is the same question.
Next time I'm going to let you phrase it for me, please.
No, that's fine. It's a version, it's a variant.
Yep, but that's exactly right. Yes.
Sergio, are you seeing the diagram? I don't know if you can see it now, but and I think this is the visual depiction of Arthur, what you were just saying as well, right? So there's different ways in which you can imagine that the primary LM as the controller could be an LLM, and then all the other ones being like SLMs. I think that was my takeaway reading it, that at least the way you should proceed is replacing some things that are a little bit more like smaller scope, and then gradually kind of like see if even like your coordinator can do more, can become an SLM. But now when I'm going through it, I'm not finding anything explicit. That was just my takeaway. So I don't know if they mentioned it explicitly to you. Did anybody see an explicit call to it, or it just kind of became like obvious reading it that you wouldn't want to replace this one with an SLM as the first thing to go?
Yeah, I think it's the latter. I do feel like the paper is written from someone's almost like a strong viewpoint that, I want to push SLMs. So they probably won't say that explicitly, but that is the intention. Even down below when they're talking about, hey, once you have enough data and you're doing evals on your tasks, you can then train an SLM or like figure out if an SLM can do the same job as an LLM, but start with an LLM is what they're saying there. So, yeah.
That answers
But I think there's going to be a hybrid one. There's no way which goes back to this other question I think we were discussing, question number 2, where it's like, do you train, do you fine tune a SLM for every single job? That's a lot of work, and I don't think there's consensus on it at all.
But do you think like using the hybrid approach where you were using SLMs for smaller tasks versus LLMs for the bigger ones and the agents, will that hamper the quality of the results it returns? That's my only concern. Like the quality might be affected because when I build agents and when I try to use different LLMs in a multi-agent system, the results actually become slightly weird in the sense like the quality gets affected. Whereas when I'm using just one LLM for all the agents, no matter which one, the quality stays pretty sane or consistent. So that's my only concern. Like, how will it affect when we're using SLMs and LLMs in one multi-agent architecture or system?
I'm going to chime in. Just wanted to bring out this point. Something we've explored. Hybrid doesn't work for us in high volume environments where you need to make a prejudgment on any sort of downstream events, which might need, say, LLM processing. And what we've been able to do successfully there is use these SLM as a pre-filtering there to sort of adjudicate what needs further processing and what needs further sort of execution at a very complex level. So think of it as like a separation between a high-speed lane on a highway or toll, wherein you're just quickly filtering out any sort of irrelevant events and just focusing on the main ones. And that has worked really well in like a high volume, high velocity environment. Yeah.
Okay.
Any other comments? And there's something I forgot to say up front. So if you're asking a question, if you wouldn't mind, if you're not in your PJs and you don't look like Albert Einstein because you haven't done your hair this morning, which is what I look like when I don't, if you'd put your camera on so we can see you asking the question. So Yassine, you are up, if you don't mind.
Yeah, of course. I don't think I've done a very good job on phrasing the question, and I think it also like touches upon what Adam said earlier about building a product and being in that mode where you just select the best model up front. Exactly the better lesson. Thanks, author. I feel like the authors were arguing very hard in that direction that you can use LLMs, it's better for the environment, it makes sense for very narrow tasks, but doesn't ultimately everybody would just like to have one smart agent and not have to deal with SLMs, not have to deal with the orchestration, not have to deal with thousands sub prompting, etc. And I just wanted to understand whether the group feels that sentiment or whether I'm missing something. And yeah,
I have an opinion on this as a big fan of the bitter lesson.
go ahead.
I think that it's, or at least I think you could make a good argument that, hold on, just, just riffing, right? I haven't thought about it all that much, but it could be that the reason that this feels to me like probably like the most interesting argument here is that you could go back to the passenger seat. The idea isn't that you are actively always constantly feeding in more data for fine tuning and you're the one that's always active in control, but that the system could, at least in principle, automatically, organically evolve to such an extent that it only really uses a small language model. Whether, yeah, that is somehow like fine. And you, if I were to put you in the driver's seat, maybe you wouldn't even know what should be the small language model in the first place, and what would be the ideal place to replace the large language model with in your entire agent architecture. And if that's the case, it's perfectly consistent with the bitter lesson, where, yeah, although I could see how it would be, yeah, it's like a flavor of it, right? So the system is continuing to evolve without so much human guidance, unless you feel like you need to step in to introduce guardrails or whatever you need. But on its own, it can already kind of self-optimize. And the output of that self-optimization will be small language models.
I'm going to stop us here. It's 9 o'clock on the dot, and part of my job is to keep us on time. And my whip is out, Adam, so I'm going to stop you. Thank you, everyone. This is a great discussion. I'm sorry, Artem, we didn't get to your question. The participation is wonderful, and thank you for Samantha for sharing your experiences and the other folks who did as well. Look forward to catching up with you all offline. Again, you have our links, and please feel free to send us and do that. And we will see you all next month at the reading group. Take care. Be well.
Thank you, everybody.
Bye.
Thank you. Bye.